Alternative periodic tables. Alternative periodic tables are tabulations of chemical elements differing significantly in their organization from the traditional depiction of the periodic system. Several have been devised, often purely for didactic reasons, as not all correlations between the chemical elements are effectively captured by the standard periodic table. Alternative periodic tables are developed often to highlight or emphasize different chemical or physical properties of the elements which are not as apparent in traditional periodic tables. Some tables aim to emphasize both the nucleon and electronic structure of atoms. This can be done by changing the spatial relationship or representation each element has with respect to another element in the table. Other tables aim to emphasize the chemical element isolations by humans over time. Charles Janet's left-step periodic table is considered to be the most significant alternative to the traditional depiction of the periodic system. It organizes elements according to orbital filling and is widely used by physicists. Compared to the common layout, the left-step table has these changes. A modern version of the periodic table is constructed by Valery Zimmermann, named the Adoma periodic table. Its structure is based on the 4 quantum numbers of the electron configuration, hence it has a 4-dimensional base. In Theodore Benfei's periodic table, the elements form a 2-dimensional spiral, starting from hydrogen, and folding their way around 2 peninsulas, the transition metals and lanthanides and actinides. A superactinide island is already slotted in. The chemical galaxy is organized in a similar way. Timothy Stowe's physicist's periodic table is 3-dimensional with the 3 axes representing the principal quantum number, orbital quantum number, and orbital magnetic quantum number. Helium is again a group 2 element. Paul Giger's 3D periodic table consists of 4 connected billboards with the elements written on the front and the back. The first billboard has the group 1 elements on the front and the group 2 elements at the back, with hydrogen and helium omitted altogether. At a 90 degrees angle, the second billboard contains the groups 13 to 18 front and back. 2 more billboard each making 90 degrees angles contain the other elements. Ronald L. Rich has proposed a periodic table where elements appear more than once when appropriate. He notes that hydrogen shares properties with group 1 elements based on valency, with group 17 elements because hydrogen is a nonmetal, but also with the carbon group based on similarities in chemical bonding to transition metals and a similar electronegativity. In this rendition of the periodic table, carbon and silicon also appear in the same group as titanium and zirconium. A chemist's table with an alternative positioning of hydrogen, helium, and the lanthanides was published by E. G. Marks and J. A. Marks in 2010. From Mendeleev's original periodic table, elements have been basically arranged by valence and the repetition therein. Over the years and with discoveries in atomic structure, this schema has been adjusted and expanded, but not changed as a principle. The oldest periodic table is the short-form table by Dmitry Mendeleev, which shows secondary chemical kinships. For example, the alkali metals and the coinage metals are in the same column because both groups tend to have a valence of 1. This format is still used by many, as shown by this contemporary Russian short-form table, which includes all elements and element names until Rankinium. H. G. Deming used the so-called long periodic table in his textbook General Chemistry, which appeared in the USA for the first time in 1923, and was the first to designate the first 2 and the last 5 main groups with the notation A, and the intervening transition groups with the notation B. The numeration was chosen so that the characteristic oxides of the B groups would correspond to those of the A groups. The iron, cobalt, and nickel groups were designated neither A nor B. The noble gas group was originally attached to the left side of the periodic table. The group was later switched to the right side and usually labeled as group Adia. In the extended periodic table, suggested by Glenn T. Seaborg in 1969, yet unknown elements are included up to atomic number 168. Theoretical periods above regular period 7 are added. In the research field of superatoms, clusters of atoms have properties of single atoms of another element. It is suggested to extend the periodic table with a second layer to be occupied with these cluster compounds. The latest addition to this multi-story table is the aluminium cluster ion Al7, which behaves like a multivalent germanium atom. Spiral periodic table. The ring of periodic elements. Curled ribbon periodic table. Circular periodic table. Alternative circular periodic table. Spiral periodic table. Mendeleev's flower. Binary electron shells periodic table. Stowe periodic table. Zemachinsky and Bailey periodic table. Adoma periodic table. Newlands revisited. Pyramidal periodic table. Stowe-Janitsary with 3d electron orbitals. 4d Stowe-Janitsary periodic table.